Day 31. Your automation dies. Same inputs, but suddenly the outputs are wrong, or missing, or quietly delayed. Your dashboards look fine. Alerts stay green. Everyone points at the model like it woke up and chose chaos. Then you dig for hours and find nothing obvious. That contradiction is the worst part. It worked yesterday. It fails today. Nothing changed, except everything around it. The real cause is hidden, and your system is drifting. Moving to slide 2. Drift is what happens when your automation sits on moving ground. APIs change behavior without a version bump. A permission that used to be broad gets tightened one checkbox at a time. A field name gets renamed, or a null starts showing up where a string used to be. Rate limits shift quietly, and now your traffic pattern trips a threshold you never knew existed. Then, retries kick in and make it look like resilience, while actually smearing one clean failure into 1,000 slow random ones. If you only monitor uptime, drift will beat you. Stability comes from watching contracts, not just endpoints. Moving to slide 3. Your automation is not one thing, it is a chain, and every link can be the culprit. A connector can change its mapping. A webhook can start delivering late, out of order, or duplicated. Your queue can back up. Then your scheduler fires again, and now you have 2 runs competing. Your CRM might reject a write because a validation rule changed. Billing might flip a customer to past due, and your workflow suddenly loses access to a feature flag. Your LLM call might still succeed, but your embedding store could be timing out, so retrieval returns thin context and the model sounds confident and wrong. Then, there are humans. An approval inbox gets flooded, someone creates a filter, and approved becomes never seen. The way you debug this is to name every dependency, then give each one a health signal you can actually trust. Once you see the chain, the failures stop looking random, they start looking inevitable. Moving to slide 4. Even with healthy dependencies, hidden assumptions can quietly poison outputs. You assume the input format stays stable, but one team adds a new column or changes date order, and your parser still runs while meaning flips. You assume labels mean one thing, but priority becomes customer priority instead of urgency, and routing breaks. You assume one account owns access, then that person leaves and tokens get rotated. You assume latency stays acceptable, then a new compliance scan adds 2 seconds and your timeouts start firing. You assume edge cases stay rare, then a new product launch turns them into the majority. The fix is to write down your assumptions and convert the critical ones into checks that fail loudly. That discipline is what keeps your prompts from decaying in place. Moving to slide 5. Prompt rot is real because prompts are treated like copy, not code. Someone copies instructions into a new workflow and trims one sentence that was doing heavy safety work. Context grows uncontrolled, so the model starts prioritizing old chatter over the current task. Examples go stale, and the model learns a style that no longer matches your product, policies, or pricing. New intents sneak in through just add one more thing until the prompt becomes a junk drawer. And tone drifts from brand because different people patch it for their own needs. Treat prompts like versioned artifacts. Lock a canonical source, add tests with fixed inputs, and review changes like you would a billing rule. When your words are the interface, a broken data contract is only a matter of time. Moving to slide 6. Your pipeline didn't get worse. Your data contract broke. One day you wake up and new nulls are everywhere, even in fields that used to be rock solid. IDs that were numeric become UUIDs, or the other way around, so joins silently miss. Time zones shift, and suddenly daily reports look off by 1, but only for some regions. Decimals arrive as strings, so calculations either fail, or worse, coerce and drift. Then duplicates flood in, because a source changed its retry behavior, or a key stopped being unique. None of this feels like a big dramatic outage. It feels like death by 1,000 paper cuts, and if you are not explicitly watching for these contract breaks, they will keep shipping quietly. Moving to slide 7. Failures go unseen when success is fuzzy. If your success metric is something like the job finished, you are measuring the wrong thing. You need to know whether the output is correct and complete, not just produced. Logs without request context are another trap. If you can't trace a bad row back to a source call, a file version, or a run ID, you can't debug quickly. Most teams also lack golden test cases. A small set of known inputs with expected outputs catches format flips and time zone shifts immediately. And you need output quality checks that run every time, like row counts by partition, uniqueness of keys, null thresholds, and schema expectations. Finally, incidents need an owner. If nobody is on the hook to close the loop, the same minor failures will keep reappearing for months. Moving to slide 8, the 30-day trap is what happens after a clean launch. Week 1, everyone is watching dashboards and fixing edge cases fast. By week 4, attention moves on. Tiny changes accumulate. A vendor adds a field, a product team renames an event, a backfill gets run with slightly different filters. None of it is catastrophic, but the system slowly drifts. Meanwhile, tribal knowledge disappears. The person who knew why a weird transform exists goes on vacation, changes teams, or just forgets. Then one person becomes the bottleneck for every question, every incident, every "is this normal?" Fixes happen in hot patches and quick PRs, but nobody records the why. That is how pipelines become fragile without anyone noticing. The only sustainable counter is to make the system explain itself. Moving to slide 9. Documentation is the fix, because it turns hidden assumptions into checkable behavior. Start by writing what the pipeline is supposed to do, in plain language, then make it testable. For each dataset, state the meaning of key fields, the allowed formats, and the invariants you rely on, like order ID is unique per day, or event time is UTC. When a source breaks that promise, you want an alert that points to the exact promise that was violated. Freeze assumptions in writing. If you assume late data arrives within 48 hours, write that down and wire your backfill logic to it. If you assume retries can produce duplicates, document dedupe keys and where dedupe happens. Expose dependencies and owners. Every upstream source and downstream consumer needs a named owner and a contact path. Define success and failure with numbers, not vibes, like freshness, completeness, and acceptable null rates. Good docs are not essays. They are operational controls that let any teammate hand off, debug, and restore confidence quickly. Moving to slide 10. Doc 1 is your system map. It is the fastest way to stop guessing. List inputs, outputs, and destinations. For each input, write where it comes from, how it arrives, and how often it is expected. Include every integration, even the temporary ones. Then add the auth method per connector, like OAuth app, service account, key rotation schedule, and who can renew it. Most surprise outages come from auth expiring with no clear owner. Next, document data stores and retention. Where does raw land? Where do transform tables live? What gets deleted after 7, 30, or 180 days? If you do backfills, note what historical range is possible without breaking cost or quotas. Finally, give every box a single owner, not a team alias, a person who will root the issue. When something breaks at 2 a.m., the system map turns panic into a checklist, and once the map exists, you are ready to specify exact behavior, not just topology. Moving to slide 11. Doc 2 is your behavior spec. It is where you make the model predictable on purpose. Start with exact trigger conditions. Write them like if statements you could hand to an engineer. If the user asks for refunds, if the request contains personal data, if confidence drops below a stated bar. Then give decision rules in plain terms. What should it do, in what order, and what should it say? Keep the rules observable. Use checks like required inputs present, policy category, risk level, and time sensitivity. Add fallbacks for uncertainty. If the model cannot verify a fact, it must ask one clarifying question or switch to safe general guidance. If a tool call fails, it retries once, then returns a partial result with a clear status. Put escalation and approvals in writing. Define which cases require human review, who owns the approval, and what evidence must be attached. Finally, define what it must not do. No guessing numbers, no inventing citations, no taking irreversible actions. When you can read this doc and simulate the behavior in your head, you are ready to lock it down with a clean contract for the data. Moving to slide 12. Doc 3 is the data contract. You are removing ambiguity from every input and output. List required fields with types and be strict. User ID is a string, timestamp is ISO 8601, locale is a BCP47 tag, confidence is a float from 0 to 1. Then explicitly mark allowed nulls and defaults. If planned tier is missing, default to free. If time zone is null, assume UTC and say so. Include 2 or 3 example payloads that are valid, including 1 minimal payload and 1 fully populated payload. Version schema changes. Add a version field and document what breaks between versions. End with downstream impact notes. If you rename a field, which dashboards, evaluators, or tool calls will fail. A good data contract makes failures loud, fast, and easy to diagnose, which is exactly what your test pack should enforce. Moving to slide 13. Doc 4 is the tester pack. You keep a golden library of inputs that represent real traffic, plus the expected output snapshots. Add edge cases, adversarial prompts, and tool failure simulations. Replay the suite on a monthly schedule and on every significant change. Define pass-fail thresholds upfront, like exact JSON shape, banned content checks, and minimum quality scores. If it is not measurable, it is not a test. Moving to slide 14. Doc 5 is a runbook. This is what you open when something breaks at 2 a.m. Start with the top failure modes, written in user symptoms and system causes. Wrong routing, missing fields, tool timeout, policy overblocking, policy underblocking. Then tell yourself exactly where to check logs, with the key filters and the one query that usually reveals the issue. Include rollback and safe mode. Define what features can be disabled, what model can be pinned, and what the degraded experience should look like. Add who to page first, in order, with ownership boundaries so you do not waste time. Finish with a post-mortem template. What happened, impact, root cause, what you changed, and what you will monitor. A runbook turns chaos into a repeatable routine, and that only stays true if your docs keep evolving. Moving to slide 15. Keeping docs alive is a process, not a reminder. Make doc updates part of the same PR that changes behavior, prompts, tools, or schemas. If the model's behavior shifts, add a changelog entry that says what changed, who approved it, and what risks increased or decreased. Assign an owner for each doc and schedule a monthly review with a short checklist. Are trigger conditions still accurate? Are payload examples still valid? Do tests still match production traffic? Does the runbook match current on-call reality? Tie alerts to outcomes, not vibes. Monitor things like refusal rate, tool error rate, escalation volume, and user-reported harm. Put all of it into one health dashboard so you can spot drift early. When your docs are treated like production code, you stop arguing about what the system should do, because the loop from intent to evidence stays closed. Moving to slide 16. Close the loop. Pick one workflow that keeps breaking, just one. Write the map of how it actually runs today. Then write the spec for how it should run. Add a simple contract. Who does what, by when, and what done looks like. Now protect it with 10 golden tests, the checks that catch the same failure before it ships. Put a monthly replay on your calendar to run the workflow, score it, and update the tests. Finally, comment your failure pattern in the doc, so future you cannot pretend it was random. If you want more systems like this, subscribe. In the comments, tell me the one workflow you are fixing first. Technology changes fast. Great systems last.